Okay. Uh, Hello, everybody, and thank you to the steering committee for letting me talk about the Saturn system mission concepts that have come out over the past approximately 10 years. Next slide, please. I'll be talking about these topics, the recommendations of CAPS for some Saturn mission concept studies, some general recommendations. I'll be talking about some of the mission concepts, a couple of which we've already heard about, so I'll just very briefly mention those. I'll go to a little more detail about other Saturn mission concepts that are out there, and then a brief discussion of gaps in the studies that probably should be addressed during this next planetary decadal survey. Next slide, please. CAPS made recommendations in their 2019 report. You see at the bottom a URL that allows you to get to that report. They didn't recommend any specific mission concepts, but they did note that since the last decadal survey, and of course a fair amount of the Cassini extended mission occurred after that last decadal survey came out, that the wealth of discoveries that came out of Cassini has just whet our appetite to go back to the Saturn system. CAPS emphasizes that the Saturn, Titan, and Enceladus science objectives rise to the top. They made some really supportive reference to the Titan-Saturn system mission, the study and the concept. If you heard David Smith's talk 2 days ago, he mentioned that one of the panels on the last decadal survey had a problem with the independent cost estimates, and this was the one that had the greatest problem. This is the one that the panel came out vocally and said there's something wrong with this. It was letting lower tier science objectives drive the mission cost. And so there was some disagreement about that mission cost. Anyway, one of the things they talked about was that since the last decadal survey, there have been multiple subsequent lower cost concepts to come out that would do subsets of the TSSM science objectives, some of them discovery concepts, some of them new frontiers concepts. For example, there's the Enceladus Live Finder, the Titan Mare Explorer, and the Journey to Enceladus and Titan jet. There's also been an ESA M-class mission proposal that closely aligns with the TSSM science objectives. CAPS came out supporting studies of smaller missions, including small flagship missions, that would marry some of these discovery and new frontiers concepts, and they may come up with concepts that are viable as smaller flagship missions. Next slide, please. I'm going to talk about now a study that was accepted by the PMCS program. Next slide, please. And I will be brief about this. This is the Orbilander concept that we heard about yesterday. Orbilander itself is not a brand new concept. In 2007, there was a JPL, what they called RMA, Rapid Mission Architecture study, that first put out the Orbilander concept, but it has certainly been advanced by this study. We heard about that, so I'm not going to go into much detail on that. Next slide, please. Down at the bottom, you'll see the URL where you can access the presentation that was made in August about the results of this mission study. And I just have some of the details here for completeness. Next slide, please. There are some other Saturn mission concept studies that are out there, things since the last decadal survey, and some of them that kind of overlapped with the last decadal survey. Next slide, please. One is the Saturn Ring Skimmer mission. Now, OPAG heard a presentation about this in April of last year, and this is the title slide from that presentation. Matt Tiscarino has told me that the team has changed somewhat since then. So down at the bottom, there's a URL that allows you to get the presentation that was made to OPAG back in April Next slide, please. And down at the bottom of this one is a URL to a white paper that gives you a more recent update. There's been quite a bit of subsequent work on the Saturn ring skimmer concept. And so quite a few things have changed since we saw it in April of last year. The PI is still the same, but the team has changed somewhat. There have been some additions. The mission concept, it's an 8 to 9 year transfer to the Saturn system, although that's highly dependent on which year that you launch. It is possible that you could be shorter than that, but it might be longer, and it just depends on when they get a launch opportunity with whatever opportunity they're proposing to. You get to Saturn and insert into orbit propulsively, and then there's a 5-month Titan-driven pump down to a very eccentric orbit with a low perichrone, so you're getting in close to Saturn, and a very low inclination of that orbit. That very low inclination and the eccentricity gives you very close passes across the rings, about 4 per month over the duration of the mission, and it gets very close to the ring plane, about hundreds of kilometers in some cases, instead of the tens of thousands of kilometers that Cassini got from the ring plane. Now, the eccentricity gives you a high relative velocity with respect to the ring particles, which is unlike a previous mission concept, the Saturn Ring Observer, which would actually hover over the rings. It would match the orbital velocity of the particles in the rings, and you get zero relative velocity observation of those ring particles. But also, unlike Saturn Ring Observer, it needs, and when I say it, I mean Saturn Ring Skimmer concept, needs no new tech development to implement. The science goals are not just rings. It's a multidisciplinary mission. So they are indeed looking at a lot of things concerning rings. They're examining the processes within a particle-rich astrophysical disk, and especially a collisional astrophysical disk. And then they're looking at the compositional evolution and the transport rates within the rings. So that should give us something of a better idea about how old the rings are, and possibly confirm Cassini's suggestion that these rings are quite young. But they will also do interaction studies of the rings, the magnetosphere and the atmosphere, and then look at dynamical processes within Saturn's atmosphere. And then with gravity science, look at Saturn's interior, and especially the variability of that interior and any asymmetries as they're reflected in the structures of the rings and in the gravity science. Next slide, please. In the previous Planetary Science Decadal Survey, there were a couple of Saturn probe mission studies. There was a first study that they called a technology trade study that was a fairly low fidelity study, that the main idea was to see if there were any new technologies required for a Saturn probe mission. It turned out there was one, and that was for the heat shield, the thermal protection system material for the heat shield, which at the time, the heritage carbon phenolic was going away and they needed something to replace it. Well, that has now been replaced with the heat that has come out of NASA Ames. That is now at TRL-6. And so the Saturn probe mission now requires no new technologies. That study compared power systems and looked at trajectories and the telecommunications opportunities that different trajectories might give you. And it gave a low fidelity cost estimate. And that was not enough to determine whether or not it was actually a New Frontiers candidate. So they did a follow-on study called a point design study that was higher fidelity than the trade study. And it generated a subsystem level flight system design that allowed actually doing this higher fidelity cost estimate. And that cost estimate verified that, yes, this is a viable New Frontiers candidate. And the Saturn probe mission was added to the New Frontiers science list. Now, there was a New Frontiers proposal that came out for a Saturn probe. There might have been more than one. I'm aware of one, but it was not selected. And that proposal and the results pointed out a problem, a possible problem with the definition of the Saturn probe mission. And that involves the architectural conflict, possible architectural conflict with the science scope and the mission duration. People are saying that you're doing a science mission that only lasts about an hour. And there's a problem with the science that you can do in only an hour for a $1 billion mission. So there have been suggestions that it should be folded in with other science objectives. And excuse me just a minute. Got a solicitation call there. Anyway, that possibly it should be folded in with other science objectives, which give you a somewhat longer mission, and it advances the mission value somewhat. So it might be that needs to be resolved before the New Frontiers concept is really viable. Next slide, please. There have been some gaps left by these previous studies. Now, the Titan-Saturn system mission, of course, studied Titan orbiter science, but since Titan-Saturn system mission was essentially said non-viable, it was deemed non-viable, we need to take a look at what of the Titan orbital science objectives are viable from New Frontiers or smaller flagship missions. There was a New Frontiers proposal for the Oceanus mission, but that was a proposal and that's not publicly available as a study. So that you can't count that as a study. There's a lot of Cassini's mission was after the TSSM mission was studied. That was studied in 2007 and 2008. So there's a lot of Cassini occurred after that. And it's possible that some of the discoveries that Cassini made and some of the data that Cassini took would lead to expansion of those objectives or refinement of those objectives. So that needs to be looked at. One of the things that, or a couple of the things that you can do with a Titan orbital mission is getting global high resolution mapping. We have not quite global mapping, and certainly not all of it is at high resolution. So we need to do that at multiple wavelengths. Most of those would be IR wavelengths in the IR windows, and also with SAR, getting higher resolution SAR. And we'd like to get some repeat coverage of certain areas that would allow monitoring of changes on the surface. We need to do some more work with the interior ocean, and most of that would be done with gravity science, although there are a few other things you can do. But the problem with the gravity science is that you're limited by that thick atmosphere that limits how close to Titan you can get, and that limits how high a harmonic of the gravity field that you can get because of those high altitude orbits. Next slide, please. To summarize, we've had some coverage by the post-Cassini concept studies of Enceladus, and there are multiple architectures that have been looked at there with landed Enceladus orbit and flybys from Saturn orbit. We've had some ring studies such as Saturn Ring Observer and Saturn itself with the Saturn Atmospheric Entry Probe. And then we've got a more general Saturn system study with the Saturn Ring Skimmer, although there hasn't been a concerted publicly available study of Saturn Ring Skimmer. During the next planetary and astrobiology decadal survey, there are a couple of gaps that need to be filled. The Titan orbital science mission concepts and objectives to be examined, and the architecture of the Saturn entry probe, the science objectives there to make it a more viable concept. Next slide, please. I will end there, and of course, I will take questions at the question session at the end of this session. Thank you.